Kalau itu dalam
Welcome to
Andalas University.
Universitas Andalas is a state university established on September 13, 1956. The main campus is located in Padang, the second in Payakumbuh, and the third in Dharmasraya. Since August 31, 2021, Universitas Andalas becoming the legal entity state university. The vision of Universitas Andalas is to be an outstanding and dignified university with 4 missions and a long-term strategy for 20 years. Universitas Andalas is accredited superior by the National Accreditation Board and has been in the first cluster along with 15 universities based on academic staff research performances. 15 study programs have been internationally accredited or certified by ABET, IABEE, FIBAA, ABST 21, and AUNQA. The university supports study programs to meet international quality standards. Study programs that meet the requirements are facilitated to be assessed by the international accreditation boards, such as the Royal Society of Chemistry, the Foundation for International Business Administration Accreditation, and by the Accreditation Agency for Study Programs in Engineering, Informatics, Natural Sciences, and Mathematics. Universitas Andalas has made policies to ensure high-quality education, including the academic guidance, the ethical conduct, the guidance for students' internship, student exchange, and students' mobility programs. The university also have had a rector's degree on internal quality assurance system, the internal quality standards, and the manual of internal quality assurance system. The total number of students is more than 30,000 who come from various provinces in Indonesia and other countries. They were spread over 137 study programs at the vocational, undergraduate, professional, master or doctor levels. Many scholarships have been offered to the students. The teaching and learning process is held in common classroom with various capacity. The internet bandwidth is 165 Mbps, which can be accessed using LAN and Wi-Fi. Supporting facilities for students include dormitories, health clinic, university hospital, mosque, event center, student center, career and development center, cafeterias, and various sport facilities. There are 1,462 academic staff consisted of 161 professors, 380 associate professors, and 506 assistant professors. The academic staff also conduct researches and produce publication in reputable journals. The academic staff to student ratio is 1/19, and the supporting staff to student ratio is 1/17. To ensure the sustainability of the campus in the future, Universitas Andalas has had an integrated waste management system, an integrated water management system, and a micro hydropower plant inside the campus.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi washabihi rasulillah jemaah. Yang sama-sama kita hormati Bapak Pimpinan Fakultas Teknologi Pertanian Universitas Andalas, yang dalam hal ini diwakilkan oleh Bapak Wakil Dekan 1, Bapak Dr. Devi Andika Permata. Kemudian yang sama-sama kita hormati Bapak Ibu pimpinan Departemen Teknologi Industri Pertanian, Departemen Teknologi Pertanian dan Biosistem, dan Departemen Teknologi Pangan dan Hasil Pertanian, dosen, dan para guru besar yang ada di Fakultas Teknologi Pertanian Universitas Andalas. Kemudian yang kami banggakan mahasiswa yang sudah hadir pada kegiatan hari ini, pada kegiatan Stadium General World Class University Fakultas Teknologi Pertanian Universitas Andalas tahun 2020. Hari ini kita akan mendengarkan kuliah umum dengan dua topik yang berbeda. Yang pertama yaitu teknik ekstraksi komponen bioaktif dalam aplikasi teknologi pertanian. Yang kedua, tren riset nanoselulosa past, present, and future. Alhamdulillah, pada hari ini sudah hadir dua dosen tamu kita, yaitu Profesor Dr. Zaibunisa Abdul Halie. Kepada Profesor, selamat datang Prof pada hari ini. Mohon aplausnya. Kemudian yang kedua, Profesor Dr. Insinyur Muhammad Sapuan Salib. Selamat datang Prof. Tidak lupa pula kami menyapa mahasiswa internasional yang ikut program World Class University di Fakultas Teknologi Pertanian, yaitu Halimatus Saidah Abdullah. Selamat pagi. Aplaus, tolong. Kemudian Nur Fadilah binti Madia. Selamat pagi. Baik, kita masuk ke agenda pertama sebelum penyampaian kuliah yang disampaikan oleh dosen tamu kita. Kita minta sambutan dari pimpinan Fakultas Teknologi Pertanian terhadap kegiatan Stadium General World Class University Fakultas Teknologi Pertanian tahun 2023 ini kepada Bapak Wakil Dekan 1, Bapak Dr. Andika Permata, Devi Andika Permata. Waktu dan tempat kami persilakan. Assalamualaikum warahmatullahi wabarakatuh. Kita bacakan kepada pimpinan kita di bawah semoga. Juga kita bacakan kepada Allah Subhanahu wa Ta'ala yang telah memberikan rahmat dan karunia-Nya sehingga kita dapat berkumpul di gedung ini dalam rangka Stadium General. Maaf ini selalu salam kepada pimpinan kita dan Ustaz Muhammad SAW. Yang kami hormati Bapak Profesor Dr. Insinyur Muhammad Sapuan Salib dari University Putra Malaysia. Yang kami hormati Ibu Profesor Dr. Zaibunisa Abdul Halie dari University Teknologi Malaysia. Kemudian yang kami hormati adalah Ibu Heli Halimatus Saidah dari Ibu Nur Fadilah dari University Putra Malaysia yang sudah kurang lebih 2 minggu berada di Universitas Andalas dan mengikuti beberapa program dari Fakultas Teknologi Pertanian Universitas Andalas. Yang kami hormati Bapak Ketua Departemen, Bapak Profesor Santosa dari Departemen Teknologi Industri Pertanian. Yang kami hormati Ibu dosen yang ada di Fakultas Teknologi Pertanian Universitas Andalas, baik dari Departemen Teknologi Industri Pertanian, Departemen Teknologi Pangan dan Hasil Pertanian, dan Departemen Teknik Pertanian dan Biosistem. Pada hari ini kita akan melaksanakan Stadium General dengan 2 tema yang berbeda seperti yang disampaikan oleh Pak Elman tadi. Yang pertama dari Ibu Profesor Zaibunisa Abdul Halie terkait dengan teknologi ekstraksi di bidang pangan dan beberapa produk pertanian. Kemudian nanti dilanjutkan oleh Bapak Profesor Dr. Insinyur Muhammad Sapuan Salib terkait dengan tren penelitian dan nanoselulosa baik masa lalu, saat ini dan akan datang. Kami mengucapkan terima kasih kepada Bapak Ibu yang sudah berkenan datang ke Universitas Andalas untuk berbagi ilmu kepada adik-adik mahasiswa. Kalau tidak salah di sini ada mahasiswa dari program studi S1 dan mahasiswa dari program studi S2, baik itu dari Departemen Teknologi Pangan dan Hasil Pertanian, dari Departemen Teknologi Industri Pertanian, ataupun dari Departemen Teknik Pertanian dan Biosistem. Saat ini juga berlangsung kuliah oleh Prof. Eji Morimoto dari Kobe University di Departemen Teknik Pertanian dan Biosistem. Semoga apa yang kita laksanakan hari ini dapat membuka wawasan kita, menambah pengetahuan kita, terutama kepada adik-adik mahasiswa untuk melaksanakan penelitian untuk menyelesaikan tugas akhirnya. Permohonan maaf kami sampaikan dari Bapak Dekan, karena dengan jadwal yang bersamaan, Bapak Dekan juga ada menguji mahasiswa magister untuk menyelesaikan studi akhirnya. Itu saja atas kesempatannya yang berkenan hadir dan berbagi ilmu bagi kami di Universitas Andalas dan masyarakat Sumatera Barat pada umumnya. Karena beberapa kegiatan kita juga ada community services yang kemarin juga Prof. sudah ikuti juga. Kita akhiri saja dengan mengucapkan alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih kepada Bapak Wakil Dekan 1 Fakultas Teknologi Pertanian atas sambutannya. Baik, berikut kita masuk ke agenda berikutnya, yaitu penyampaian kuliah yang akan disampaikan oleh Profesor Dr. Zaibun Nisa dengan topik teknik ekstraksi ya. Sebelumnya saya akan menyampaikan profil beliau. Berikut profil beliau. Beliau sekarang merupakan profesor di Food Technology Program Faculty of Applied Science, University Teknologi Mara. Pendidikan beliau PhD, Faculty of Science and Technology, School of Chemistry and Food Technology, University Kebangsaan Malaysia. Master degree didapat dari Departemen of Food Technology, Faculty of Food Science and Technology, University Putra Malaysia, dan bachelor didapat dari Faculty of Food Science, School of Biological Science, University of Nottingham. Sedikit research beliau, beliau lebih banyak tentang teknik ekstraksi sebetulnya ya, sangat cocok dengan topik kita pada hari ini. Sangat banyak publikasi yang sudah beliau publish 2019, 2018, dan 2017, tentu sangat banyak, dan ini merupakan dapat menjadi acuan bagi para mahasiswa seperti yang disampaikan oleh Bapak Wakil Dekan tadi untuk mendukung atau mensupport kegiatan penelitian nantinya yang akan dilakukan. Baik, tidak memperpanjang waktu, kepada Ibu Profesor Zaibun Nisa, waktu dan tempat kami persilakan.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semua, sihat semua? Okey, saya Zaibun Nisa dari Universiti Teknologi Mara, Malaysia. Pernah sampai ke Malaysia sebelum ni? Pernah pergi Malaysia? Mungkin S2 ya, S1 dah selesai pergi. S2 atau S3 kami alu-alukan sangat ke UiTM untuk sambung belajar. Ya. Okey, terima kasih ucapkan kepada tim daripada Fakulti Agriculture Technology dan juga Universitas Andalas umumnya yang telah menjemput saya untuk berada di sini untuk seminggu untuk share berkenaan pengalaman research dan juga ilmu yang ada lah untuk apa ni for your importance lah. Anyway, selamat datang juga kepada Prof. Safwan yang ada datang dari UPM, Universiti berlainan ya, tapi dari Malaysia. Okay, topik yang saya akan share pada hari ini adalah sample extraction technology. Okay, teknik ekstraksi. Okay, ada pelbagai jenis extraction yang kita boleh buat. Of course, in your research, you ada buat extraction ya. Setiap method perlukan extraction. Okay, so ini pada umum untuk topik kita pada pagi ini. Okay, saya akan go through in the term of principle of extraction, apakah instrumentation yang boleh digunakan untuk extraction dan juga some application. Okay, so extraction is very important for food analysis. Sebab salah extraction, salahlah result kita. Maksudnya, kalau you tak extract komponen yang perlu, silap extractionnya, data yang diperoleh akan salah. Okay, so itu penting untuk semua food analysis. So I think apply to every one of you yang tengah buat final year project ataupun akan sambung ke S2, S3 yang ini paling critical. Right? So ini some of the principle of extraction, apakah instrumentation yang kita akan gunakan dan apakah application. Okay, next slide. Okay, sample extraction issue yang selalu kita as I mentioned just now, single biggest source of error is sample handling. Okay, sekiranya sampel you tak ambil sampling yang betul, data akan diperolehan yang salah. Okay, so that is the core main method lah. Kalau silap di situ, punya result pun akan silap. Right? Single biggest bottleneck is sample analysis. So, maksudnya ini yang bottleneck. Kalau kita buat banyak dan data kita terlalu akan tidak accurate. And also, all scientists are being asked to do more with less. A lot of, maksudnya, dia tedious. Sample extraction adalah yang sangat tedious. Okay, mungkin you all boleh share juga, ada tak pernah buat sample extraction sebelum ni? Method yang selalu digunakan apa? Any one of you boleh share? Dalam analisis, apa juga analisis yang you all gunakan? Apa method of extraction yang you selalu guna? Ekstraksi. Any one of you? Kalau pernah guna, kalau S2 mesti pernah guna. Tak mungkin tak guna. Mungkin student dari Malaysia juga boleh. What is your method of extraction? Guna solvent ataupun salt extraction, guna air. Apa lagi? So itu soil sebab agriculture. So kalau untuk food ada tak? Untuk food, what is the method of extraction? Any one of you? Ekstraksi. Macam mana cara you all buat extraction? Boleh seorang volunteer?
Yang AHP. Teknik ekstraksi, apa yang?
Teknik extraction. Kita pernah buat tapi tak tahu apa ni explain dia bagaimana ya. Extraction tu macam mana? Kita buat. Tapi apa teknik yang digunakan?
Naomi. Teknik ekstraksi. Apa yang kita tahu?
Fotografer boleh jawab. Extraction yang selalu guna di dalam research, dalam penelitian, mesti ada method. Kalau tak pergi buat analisis. Terima kasih.
She said size reduction. So,
Reduction.
for,
Okay. Size reduction is one method of sample preparation. But how you extract your compound of interest tu, macam mana dia extract? Yes.
solvent extraction.
Okay, solvent extraction. Yes. Okay. Mesti dia kena yang tu yang paling common. Kasi sampai kita lari ke belakang. No.
No.
Alright. Okay. So solvent extraction is the basic one. Okay. Of course, you all akan guna different solvent, different solubility. Okay. So kalau you guna polar solvent, polar compound. Kalau guna non-polar solvent, non-polar compound. So nanti guna solvent extraction. Correct. Okay. Okay. So ini problemnya of using currently available method adalah you have to use solvent yang mungkin ada toxic residue in sample. Dan kalau guna solvent seperti hexane, tetrahydrite akan ada residue. Which if you want to apply in food, dia akan mungkin ada long term. Okay, ataupun kita ada solvent tu perlu dispose of, environmental issue. Kalau you guna solvent, bila kita dah habis extract, kita akan remove. And kita terpaksa buang. So, itu adalah environmental issue. Okay, other than that, solvent also laborious. Banyak masa perlu untuk buat solvent extraction. Dan juga, masa yang lama. You need 8 hours. Kalau using normal method, 4 jam, 4 jam, masih yang lama. So, kita introduce new method whereby masih bukan adalah lebih singkat, cepat, more effective. Okay, sample extraction goal kena speed, automation, volume minimization. Ini objektif. Maksudnya, kita kena cepat supaya tak laborious. Because you want to do a lot of analysis. Kalau satu sampel pun 8 jam, masanya lama. You're wasting your time, right? So we want automation. Kalau boleh, you leave your sample, it will be automatically extract for you. Okay, and also volume minimization. Tak perlu, kalau perlu pun guna solvent yang sedikit, tak banyak, right? Okay, next one. Okay, principle of extraction, general improvement of final process temperature increases. Okay, bila kita increase the temperature, diffusion rate. Kalau kita extract, temperature mainkan peranan yang penting. Okay, selalu bila kita increase the temperature, diffusion of your sample to your solid sample, diffusion of solvent to your solid sample are not effective. So, you boleh extract lebih banyak. Faham temperature mainkan peranan dan akan increase solubility. Okay, temperature bila kita increase temperature, solubility of compound of interest bertambah baik. Okay, sometimes you have to do pre-treatment dulu. Okay, so selalunya kita akan buat acidic alkaline or enzymatic treatment so that extraction will be better. Some pre-treatment dan juga light dissolved light. Ini yang saya sebut, solvent polar akan extract polar compound, solvent non-polar akan extract non-polar. Dia light dissolved light. Okay, maksudnya kalau saya suka baru saya akan dissolve. Solvent yang suka pada polar yang polar compound. Okay, so give me an example of polar solvent. Okay, anyone in the class, give me an example of solvent yang polar. Tadi, Naomi tadi. Oh ya. So, tak payah tak Naomi siapa yang siapa yang lain boleh. Siapakah can you give me an example of solvent yang polar, bersifat polar? Water, yes. Other than that? Ethanol adalah solvent yang bersifat polar. Give me an example of solvent yang non-polar. Yeah. Anyone?
Yuk, pelarut non polar.
Yeah, very larut, but we don't use oil into extraction. Other than that, solvent. Petroleum benzene.
Excellent. Excellent.
Ya, lagi. Apa dia? Chloroform is made for kejap je nama dia selalu disebut. Okay, size reduction important sebab as you reduce the size of your sample, extraction will be better. So particle size yang lebih halus, banyak yang boleh extract daripada particle yang besar. So sample preparation memang perlu kita reduce the size of your sample. Okay, next one. Ini yang saya maksud tadi, sample type. What is the unlike of interest and solvent berkait dalam extraction technology. Okay, so sebelum you buat any extraction, objektifnya adalah you can identify this. Apa unlike yang you perlukan, apa solvent yang sesuai, what is your matrix. Okay, so ini yang perlu ditetapkan dululah, and we do some analysis dulu on this. Okay, next one. Okay, ini yang saya bagi tahu tadi, polarity tadi ya. Yang ini you have to know. Okay, in terms of polarity and the boiling point of your solvent of interest. Baru you tahu compound of interest you dissolve dekat solvent yang mana. Okay, alright. So ini the whole thing lah. Kalau tengok yang polar 9 masuk, that's the most polar, and the least one is hexane. Like say hexane on the least polar. Alright. Okay, next one. Okay, extraction techniques. You have solid and semi-solid sample. These are the most used. Is there any of the method that's really familiar to you all? Ini tak method yang pernah digunakan. Sonication, Salzlet, yeah, Salzlet, microwave, microwave extraction. Microwave biasa di rumah tu memanglah kita guna, but microwave extraction. Pernah? Belum Okay, ada juga supercritical fluid extraction and accelerated solvent extraction. Atau dipanggil ASE, PFE or PFE. These are the common synonym for accelerated solvent extraction. Alright, next one. Traditional extraction procedure yang you all mungkin dah pernah guna. Next one. Okay, ni Salzlet. Okay, ini biasa digunakan kan? So it was actually teknik ini telah ditemui pada tahun 1879. Right? 1879 people already start using this. Okay, whereby your solvent and your sample condense and you collect. Very good method actually. Tapi masalahnya dia lama sikit and you use solvent. Okay, that's the problem with this technique. Okay, next one. Okay, how it works, boiling solvent is condensed and cooled and then pass over sample. Kita gunakan solvent untuk kita boil and kita condense and masuk dalam sample dan kita extract. Okay, itulah rupa Salzlet extraction. Same here, proven performance for wide range of metrics and like solvent, relatively independent of metrics, used as benchmark for other extraction techniques. Okay, so kalau di Malaysia, kita gunakan ini sebagai benchmark method. Okay. And also very easy to use and inexpensive. But the only disadvantage is solvent consumption tinggi. So you guna banyak solvents for this. And 4 to 48 hours per sample for complete extraction require operation in a good kalau guna solvent yang hazardous, macam hexane. Okay, last way base. Okay, these are some of the disadvantages of using this method. Okay. The solvent yang banyak, okay, but still it's effective. So effective method untuk dapatkan your sample. Okay, next one. Okay, ada juga yang bentuk begini. Pernah nampak yang bentuk begini?
No.
Belum ya? Okay, yang ini ada multiple. So, maksudnya sampel substrate yang sama, but kita guna multiple extraction at one time. Okay, so kalau dilihat kat sini, sama macam substrate tadi, tapi we can have a lot of sample extraction at one time. Okay, so ini sample inverse in boiling solvent and the extracted using substrate technology sama. Tapi faster than substrate sebab yang ini boleh multiple extraction. Okay, ini advantage dia. And then weakness, no walkway automation, no inline cleanup. Dia tak ada cleanup yang otomasi. Tak ada. Okay, dia perlu cleanup sendiri. Lepas kali keluar aspek itu, dia kena filter, or dia kena guna other methods to clean your sample, using solvent and all that. Alright, so what are the weakness? Potential to contamination, and then limited flexibility in extraction, all extraction at the same temperature. Temperature you tak boleh manipulate. Semuanya temperature yang sama, you extract sekali. Semua dalam balang lain. Okay, so that is the weakness of this method. Okay, next one. Ini microwave assisted extraction. Tadi ada kata ada microwave kan? Microwave diguna di rumah. Okay, same technology but you use microwave for extraction. Right? So kalau kita tengok sini, sample inverse in boiling solvent extracted using substrate teknologi yang sama. Cuma dia menggunakan microwave untuk heat up and also immerse solvent ke dalam sample supaya extraction ni tak ada. Okay, itu untuk microwave. So ini pun tak ada automation. Dependent recovery. Okay, so it is also solvent dependent recovery. Such different solvent different recovery. Okay, so yang ini pun teknik yang ada di UiTM ada, which is microwave assisted extraction. Alright, next one. Yang ini. Okay, supercritical fluid extraction. I think Dr. Damon also teaching the same topic, supercritical, yeah. So this is the method, which is method ni menggunakan extraction guna carbon dioxide. Okay, maksudnya dia tak menggunakan solvent langsung, menggunakan carbon dioxide dalam bentuk supercritical. Carbon dioxide ni diboilkan dalam temperature dan pressure yang tinggi, so it reaches critical temperature where it will be in a supercritical state. So bila dia dalam state supercritical, dia dapat dissolve better dalam sampel ni. So dia menjadi super solvent. Okay, carbon dioxide menjadi gas, tapi bila kita dah tinggikan pressure dan temperature, dia akan reach to supercritical state where dia dalam bentuk super solvent yang dapat extract almost all compound of vapors, usually non-polar. So the premium quality that you get from this method is the essential oil yang pure, the solvent, sebab carbon dioxide akan meruap. Okay, solvent yang didapat tu hasil parti yang pure. Okay, so that is the method on supercritical fluid extraction. You need carbon dioxide as a solvent, and you need a pump to extract the sample to dalam extraction cell seperti itu, then you dapat collection pile of the essential oil. Okay, next one. This is the unit that we have in our YTN. If you see the unit, we have multiple cell. Size pun berlainan. So kalau you nak extract banyak, guna sel yang besar. Kalau you nak sample prototype yang kecil, boleh guna sel yang kecil. Okay, so letak dia dalam sel tu, and you can actually extract, right? Next one. Okay. Okay. So yang ini, sorry, yang tadi tu adalah accelerated solvent extraction. Okay, sorry, balik dulu. Ni pressurized liquid extraction. Bukan SFP, SFP lain. Ini adalah another method, we call it pressurized liquid extraction. Method ini menggunakan solvent. Tadi yang supercritical guna carbon dioxide as solvent, right? Yang ini dia menggunakan solvent the beauty of this method is you boleh set the equipment to extract from the multiple solvers. So you boleh campur method number 30, 70 water. Dalam kan ada, so you set 30 water, 70 methanol. Or 30 hexane, 20 petroleum liter. You boleh, atau 3 pun boleh. You can go up to 3. So you can play around with the solvent to get the best compound of this. So for example, masa compound untuk kunyit, apa masa compound tu? Compound functional compound untuk kunyit apa? So compound yang beri medicinal value for kunyit. Anyone? Yang mesti ada. Kalau tak ada compound tu, tak ada lah medicinal value untuk yang you all minum jamu kan? Jamu kan jamu compound dia.
Apa komponen yang aktif dari kunyit?
Dari kunyit. Kurkumin. Okay, very good. Kulit hijau ni. Apa nama? Yes. Siska. Okay, Siska dapat jawab Alright, so curcumin is the marker compound for kunyit. Okay, so kalau you guna ni, you boleh optimize in term of solvent, in term of pressure, in term of temperature. What is the best method to extract curcumin out? So, katakanlah dia guna solvent yang berlainan, satu solvent boleh, atau combination of different solvent to extract the amount of curcumin in the sample. Okay, so that is the beauty of this. Ini pun automation, extraction dalam masa 15 minit boleh keluar. Okay, so bayangkan kalau you letak multiple variable solvent, variable temperature, variable pressure, multiple, semuanya diletakkan sekali, automatic. While yang kat bawah tu extract you akan keluar. Biarkan je, then you can go for your lunch and come back, extract dah tersedia. Okay, then you boleh analyze compound dalam extract yang mana yang paling tinggi. Alright, so that's the beauty of this instrument. Okay, next one. Alright, this instrument guna high pressure and temperature. Diperlukan temperature yang tinggi. Okay, so bila dia temperature tinggi can disrupt the strong salt metal injection. Temperature dia walaupun tinggi, tapi dia tak tinggi kalau kita normal extraction. Sebab kita pressure tinggi. So when the pressure is high, you don't need so much of temperature. Right? So dia play around with that. Improve penetration of the matrix and improve extraction. And also high pressure solvent remain liquid phase. Okay, solvent you walaupun dia boiling point dia, reach boiling point dia tak akan evaporate sebab dia ada pressure. Okay, dia masih dalam liquid phase untuk and it's also in enclosed compartment, dia tak evaporate. Okay, so you dapat extract. Okay, high pressure allow the solvent to penetrate the sample matrix. Okay, so that's the what you call that, the beauty of this treatment lah. Okay, next one. Alright, so yang ini in term of further detail mengenai what is the benefit. Alright, lower operating cost, shorter ROI sebab tak perlu tunggu masa yang lama. Okay, untuk get your extract. Right, ROI yang cepat, lower operating cost, higher productivity, automated operation, lower labor cost, you boleh tinggalkan, dapatkan extract. Especially kalau you are doing R&D, ya banyak. Memang perlukan banyak extract for your research. Labor ni kurang lah. Consistent result you almost similar. Setiap kali you extract, consistent result. Okay, so itu and also flow to operation inline. You can introduce inline filtration. Maksudnya dalam sel you boleh buat filtration terus. Extract dan filter kena ada dalam sel. So extract yang dapat itu adalah pure tanpa perlu difilter kan. So itu satu lagi beauty of this instrument lah. Attempt more time sample complete and like recovery save time with no re-extraction needed as the manual method. Okay, so ini kebaikan instrument ni lah. Alright, so next one, next slide. Okay, so just to overview about accelerated solvent extraction, dia adalah automated method. Use elevated temperature, you boleh play around the temperature in the instrument daripada temperature 40 to up to 200 degree. Right, temperature you boleh play around so you boleh tahu temperature optimum yang terbaik untuk sampel ni. Especially ini ada sampel-sampel yang baru okay, mungkin Pak Sebastian ataupun Pak Raymond ada sampel baru, okay, you want to see what is the marker compound dalam sampel baru tu, you can use this technique, right? So maybe you have used it before, tapi I just introduce to the student lah, right? And also quantity of solventnya rendah, 15 ml saja kalau perlu gunakan. Yang SFP tak ada solvent ni, hanya carbon dioxide. Kalau metal ni dia perlukan solvent, tapi sedikit. Okay, 15 ml saja. Compared to solvent extraction, you have to use about 100 ml, 200 ml banyak. Okay, support right range sample size and so widely used government agencies. Next one. Next slide. Inilah cara penggunaan dalam PLE, pressurized liquid extraction ataupun accelerated solvent extraction. Sample size will looks like this. Okay, so kat bawah of the cell tu kalau you perasan ada adsorbent added cell to retain difference. Kat sini dalam cell kita ada adsorbent supaya you boleh filter. Okay, yang ini pun kita boleh buat analysis different adsorbent. You can use different types. Yeah, you can use silica, you can use carbon, right? Different solvent to see how it influence the quality of the oil, right? So ini adalah cara extract cell yang digunakan. The next one. So this is to show how it looks like in cell cleanup. So dalam cell you boleh buat cleanup terus, right? In this one. Okay, so this is how the overall schematic diagram of ACE. Accelerated solvent extraction. Load sample into the sample cell. First one, sample dimasukkan dalam cell tadi. Second, fill cell with solvent. Ada pump yang akan ambil, and pump tu ambil solvent yang kita instruct the instrument. It can be multiple solvent, right? And then step yang ketiga, heat and pressure cell. Temperature dan pressure ditinggikan dalam sel. Okay, and step keempat adalah pump clean solvent into the cell. Okay, bila dah sel telah dipanaskan, solvent akan masuk dalam sel. Purge solvent using nitrogen gas. We purge the solvent. And the last one, extract ready for this. Okay, so ini semua berlaku dalam masa 15 ke 30 minit. Right? So that's the benefit of this equipment lah. Okay, next one. Okay, so this is the schematic diagram lah, how it looks like. Okay, macam yang tadi tu, but I'm just showing the schematic diagram. Mana balik yang tadi? Alright, ini saya nak tanya quiz kepada you all. Okay, so any one of you boleh tak explain what are the steps involved? Daripada step 1 sampai ke step 6. Boleh? Ada volunteer? Untuk PLE,
Ada yang bisa menjelaskan skema ini?
Yang boleh? Step involved in pressurized liquid extraction. Boleh?
Silakan.
Kalau setelah ini 10 menit, boleh. Harus real time.
Step 1 atau step pertama itu dengan memasukkan sampel ke dalam tempat sampel yang telah disediakan seperti yang telah ada pada gambar yang pertama tadi. Yang kemudian sampel yang telah tempat yang sudah ada tadi kemudian diisi dengan solvent atau pelapis yang digunakan, yang mana pelapis tersebut sesuai dengan sampel yang akan kita ekstraksi. Kemudian step yang ketiga, atur temperatur dan tekanan yang sesuai untuk sampel tersebut dengan waktu yang juga sesuai dari sampel yang akan kita ekstraksi. Kemudian yang keempat, bersihkan selalu solventnya yang dari tempat sampel itu. Yang telah tempat yang telah disterilisasi, kemudian diisi pelarut yang sesuai dengan sampel yang akan kita ekstraksi tadi. Kemudian untuk yang kelima, dikeluarkan pelarut tadi itu dari tempat solvent yang tadi itu. Kemudian yang terakhir itu ekstraksi sudah siap untuk dianalisis.
Okey ya. Winnie. Alright. Terima kasih Winnie. So, okay, so at least faham lah ya konsep untuk pressurized liquid extraction. Okay, next slide ya. Okay, yang ni pun sama dalam bentuk yang lain tapi konsepnya sama. So, load cell and then fill solvent, heat and pressure cell, full sample at pressure and temperature yang kita tetapkan, pump the solvent into sample cell, kita masukkan solvent dalam tu, and then kita keluarkan pula solvent tu kena nitrogen gas, and the last one extract ready, collection of oil, right? Okay, next one. Okay, ini adalah some of the research yang kita dah pernah buat. Okay, untuk macam mana orang guna PLE, macam yang bawah tu, experimental design approach for the extraction of volatile compound from turmeric leaf, daun kunyit, right, daun kunyit using pressurized liquid extraction. Okay, method PLE, kita optimumkan guna PLE, yang atas pun PLE untuk tiny solvent. Alright, so ini adalah contoh paper lah yang dah menggunakan teknik ini. Okay, next one. Okay, tools and technique for sample preparation. Kalau kita tengok di sini, berlainan menggunakan solvent berlainan. Okay, so kalau kita tengok kat sini, hexane, BSM, ethyl acetate, acetonitrile dan ethanol. Sampel yang sama, extract yang kita dapat adalah berlainan. So compound of interest akan berlainan, right? So itu yang menunjukkan selective extraction, maksudnya temperature of solvent selection akan mendetermine what is the analyte that you're looking for. Okay, and also ini contoh untuk blueberry extract using ACE. Same sample extracted with different solvent, fraction of analyzed, elimination of interference. Maksudnya sampel yang sama blueberry tapi guna extract solvent yang berlainan, yang akan dapat hasil yang berlainan. Ini belum kita pergi kepada pressure temperature tadi. Play around pressure temperature, extract lain-lain. Mungkin solvent yang sama dengan temperature berlainan pun akan boleh do extract lain. Dan satu lagi, combination of solvent. Ini satu solvent kan? Kalau you combine dua tiga solvent, extract yang dapat juga berlainan. Right, so that's the beauty of this extraction lah. Okay, next one. Okay, ini menunjukkan sampel yang telah di clean up. Certain sampel, macam contoh Yang ini adalah fish tissue extract, minyak ikan. Di extract, tapi yang putih itu telah di clean up guna alumina silika gel dan acidic silika gel. Okay, so you can dapat extract yang lebih jernih, lebih clean. Kalau you nak masuk dalam GC pun, your interference telah dibuang. So, gas chromatography, your peaks will be nicer sebab tak ada interference. Whereas kalau you tak filter, you straight aja extract, maybe you have darker color extract, which will interfere with your gas chromatography analysis. Okay, next one. Ini summary method of extraction secara keseluruhan. So if you see, method adalah berlainan, schematic diagram ada di tepi untuk different method of extraction. So you ada solvent extraction, microwave assisted extraction, supercritical field extraction, ultrasound assisted extraction. Saya diberitahu kita ada unit ultrasound assisted extraction di PETA. Fakulti Teknologi Agriculture Teknologi ada ya. Pateta ada ya unit tu. And fast electric field, pressurized solvent extraction, high hydrostatic pressure extraction. These are some of the methods commonly being used. Different method, different advantage and different advantage. Okay, so kalau tengok ada yang perlukan solvent, ada yang tak perlu. Okay, kalau tengok extraction time dia, solvent extraction 6-8 jam, kalau compare dengan pressurized solvent extraction 10-20 minit. Kalau SFE 10-60 minit. Ada yang 3-30 minit, microwave assisted extraction. Okay, sample size juga berlainan mengikut keperluan analisis. Right, so different method, different cara dia. Right, you can use this slide for your reference. Okay, method yang mana yang sesuai for your analysis. Okay, next one. Okay, food application. You can use method ni untuk contaminant analysis like pesticide, herbicide, PCB, dioxide analysis. And also you can look for lipid content, flavor, aroma, especially SFP kita boleh direct SFP itu tak ada solvent. You can use mati itu terus inject dalam GCMS untuk tengok flavor profile. Okay, so that is for food application you can use this method. Okay, next one. Okay, ini adalah satu lagi application using Chinese tea. Okay, so just to show that different type of Chinese tea, method yang digunakan adalah 100% water. Method 1 100% water, method 2 adalah water dan methanol. So you can see that yang 100% water extract dia rupa lain untuk dua sampel ni. So whether dicampur water and methanol, one tu extract rupa lain. Okay, so ini to show ini adalah condition you use in the PLC extraction. So rupa lain, compound of interest also will be different. Quantity of the compound of interest will be different. Right? Next one. Okay, ini ada satu lagi just to show yang sampel sama, walaupun berlainan, hasilnya berlainan. Right? So you can use that for your analysis lah to show which method, which solvent is the best. Right? Okay, next one. Lagi menunjukkan sampel yang berlainan, hasil berlainan. Okay, yang next one adalah paper. Okay, so yang ini adalah sama menunjukkan how the blueberry extract tadi itu mungkin yang nombor 4 dia lebih sesuai, I don't know. Jadi solvent yang sesuai depends to your sample. Okay, alright, next one adalah yang ini. Okay, to show that we have done on turmeric leaf extraction and other papers also. So menunjukkan a lot of advantage of using this method, and of course you can apply in industry. It will be good. Essential all industry that will be good for this method. Let's say itu saja dari saya. Any question that you want to ask? Or saya give back to the moderator. Terima kasih.
Baik, terima kasih Prof atas paparannya. Applause dulu. Baik. kita buka sesi tanya jawab. Mungkin ada pertanyaan dari mahasiswa, silakan. Kalau saya tunjuk. Oke, silakan. Ada? Oke, saya tunjuk ya. Nah. Oke, silakan. Ada pertanyaan dari mahasiswa termasuk topik ya. Topik ini menjadi basic ya, basic dalam pekerjaan. Seperti yang saya bilang, apapun proyek kita, kalau kita perlu mengetahui kualitas komponen, dasarnya itu adalah ekstraksi. Salah metode ekstraksi, salah data yang didapat. Oke, ada pertanyaan? Ini saya mendekat. Siapa kira-kira yang ada tunjuk? Siapa yang tidak melihat saya tunjuk.
Please ada Pak. Biasanya bisa.
Ada? Siapa? Oh, siap. Diinfokan nama.
Perkenalkan Ibu, nama saya Rini Sutra dari jurusan Teknologi Industri Pertanian. Tadi seperti yang telah disampaikan sama Ibu tadi kan kita menggunakan misalnya pelarut yang digunakan itu berbeda, maka hasil ekstraksinya itu berbeda juga. Jadi apakah dari sampelnya yang kita gunakan tadi itu kan sama, jadi apakah fungsinya juga berbeda nantinya atau tidak? Kita gunakan itu kan sama, jadi pelarut yang digunakan tadi kan berbeda. Apakah fungsi dari sampel yang kita gunakan itu sama atau tidak?
Oke.
Can I translate? Okay, she said that nah, ketika komponen berbeda-beda itu, tentu fungsinya akan berbeda-beda. Mohon penjelasan lebih lanjut.
Seperti yang saya mention tadi ya, sebenarnya dia sebenarnya terbalik. Apa objektif that you are looking for? Okay, so mungkin objektif of your study adalah to determine concentration of marker compound, kan? Tapi you tak tahu solvent mana yang sesuai. Okay, so study you nak tahu nak extract yang paling banyak daripada sampel yang sama, tapi compound of it is the highest. So itu objektif. So kita boleh cuba dengan different solvent perlainan untuk mendapat objektif. So itu solvent itu satu. Kita boleh juga play around with pressure and temperature. So kalau you identify solvent mana yang sesuai, then you go to next step, play around with pressure and temperature. Mungkin pressure sekian dengan sekian akan beri optimum condition untuk extract marker compound. Okay, so itu how you do the really more untuk arrangement untuk mendapatkan optimum condition to extract your compound particles dalam sampel. So itu objektifnya, dan kita go to that. Boleh?
Tapi kami perlu ditranslate. Ya, jadi dua perspektif. Dengan berbeda pelarut, komponen berbeda, atau dengan berbeda pelarut, jumlahnya. Jadi kita bisa mendapatkan jumlah yang optimum ketika pelarutnya tepat, kalau komponennya sama. Tentu, kalau tingkat kepolaran, dengan pelarut yang berbeda, jenisnya juga. Gitu, ya. Oke. Baik, terima kasih. Aplaus untuk pertanyaan. Kita namanya Reni ya. Oke, ada lagi yang lain? Oke, waduh, barisan ini ya.
Saya depannya.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan Bu, nama saya Hilya Sila. Sila izin bertanya Bu, tadi kan ada berbagai macam jenis alat ekstraksi kan Bu. Jadi kan kita juga tahu pernah ada dengar namanya ekstraksi kulit buah manggis gitu kan Bu. Kalau untuk kayak ekstraksi kulit buah manggis itu jenis alat ekstraksi itu yang seperti apa ya Bu?
Yang ini mangosteen peel, mangosteen peel. Okay. So kalau mangosteen peel, compoundnya adalah flavonoid, atau anthocyanin yang banyak dalam peel tu. Okay. So kalau you tahu itu compound of interest that you looking for, then you kena tengok solvent polar. Anthocyanin lebih kepada polar ya. So method tu determine compound of interest. Different method of course you punya anthocyanin itu berbeza. Lain antara method tu pun dah lain. Tapi kalau satu method kita tengok kita mau different solvent pun boleh. Okay, so saya recommend kalau nak guna boleh guna extracted solvent extraction. Okay, guna air pun bisa. Tapi kalau anthocyanin dia ada problemnya stability of the color compound. Dia tak stable. Bila extract makin lama makin reduce. Sebab natural colorant dia akan reduce. So you kena play around with pH. Air yang telah ada buffernya pH. Supaya you stablekan the anthocyanin. Okay, so you boleh guna ACE sebagai your method of extraction. Okay, boleh?
Dapat dipahami? Oh, mantap. Jadi pelarut polar, perhatikan pH. Karena anthocyanin sangat dipengaruhi oleh pH sama. Baik, tepuk tangan sekali lagi. Berikut kita buka dua pertanyaan lagi dari sisi sini. Ada? Oke, saya tunjuk ya, Dede, mau nanya Dede.
Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Dede Fardian dari Departemen Teknologi Pangan dan Hasil Pertanian. Jadi pertanyaan saya tadi ada metode ekstraksi yang menggunakan beberapa solvent. Saya lupa itu bagian yang mana. Habis itu pertanyaan saya itu jadi kan itu bisa dicampur
Yang
antara beberapa solvent, tapi tetap memiliki kepolaran yang sama. Jadi apa pengaruh dari bukannya beda kepolaran akan menghasilkan ekstrak yang berbeda. Apakah nanti si alat dari ekstraksinya itu akan mempengaruhi dari campuran dari solvent yang tersebut? Terima kasih.
Okay. Apa namanya tadi? Namanya Dede. Okay. Soalan TD yang saya faham, adakah polarity of the compound will be affected dengan solvent berlainan? Ya, memang akan affected. Maksudnya, apa komponen yang dalam, you boleh bayangkan tak dalam satu sampel kita, kalau extract guna solvent polarity berlainan, komponen of your compound yang you extract adalah berlainan. So, different sets of compound that you extract using different solvent. So, mengikut keperluan study. So, compound apa yang you perlukan? Kalau you perlukan compound yang bipolar akan guna sampel solvent bipolar akan extract sampel bipolar for you. Okay, so dia mengikut keperluan study. So, solvent yang berlainan akan extract compound mengikut yang light dissolve light tadi. So dia akan dissolvekan polarity compound yang sama. So extract itu akan dapat berlainan menggunakan solvent berlainan. Jika saya jawab soalan you,
So this question focus on the accelerated solvent extraction apparatus actually. So in that equipment, we can combine the ratio.
Yes.
So the question is,
Polarity.
what purpose the ratio? For
What
example,
purpose?
yes, 70-30, 50-50, say 60-40, something like that.
Okay. Purpose also different. So, for example, certain compound 100% metanol tak dapat optimum. You perlu campuran dengan air. Tapi air saja pun tak dapat optimum. You perlu campuran dua. Bila you dah campur dua tu, baru you dapat the highest compound, concentration of compound of you want. So itu yang kita buat study yang combination of solvent.
Even in the same polarity.
Even the same polarity. Sebab water extract almost all, tapi dia akan extract rubbish as well. Tapi bila you campur dengan solvent, dia akan ada some filtration. So itu yang kita kena play around with ratio as well. To get compound of interest. Faham?
So meningkatkan gradient diffusion.
Yeah,
Diffusion rate.
Yeah, diffusion rate.
Okay, thank you. Applause untuk Dede. Baik, last question. Ada pertanyaan? Wah, mantap.
Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Windy Anggreni dari jurusan Teknologi Industri Pertanian. Sebelumnya izin Ibu, saya ingin bertanya mengenai alat-alat yang berbeda tadi, kan ada waktu-waktunya, ada yang 2-3 jam, ada yang sampai 8 jam. Nah, apakah kualitas ekstraksi itu dipengaruhi oleh waktu-waktu tersebut? Dikarenakan ekstraksi sendiri kan dipengaruhi oleh tekanan dan temperatur. Nah, perbedaan waktu tentu juga akan menyebabkan perbedaan antara tekanan dan temperatur ini. Apakah kualitasnya akan dipengaruhi oleh alat saja atau akan dipengaruhi oleh waktu saja? Mungkin itu Ibu, terima kasih.
Okay. Soalan ni, kenapa kita perlu temperature, flame, temperature and time, Time, okay. So, lupa saya nak bagi tahu, time pun kita boleh monitor, kita boleh adjust. Alright, especially kalau kita guna pressurized liquid extraction tadi. So, you boleh extract dalam masa 10 minit, you boleh extract dalam 30 minit, you boleh set the instrument. So, certain compound boleh keluar dalam masa 20 minit dah maksimum. Lepas 10 minit, keluar sama je amount. Certain compound perlukan 30 minit. Duduk dalam compound pertama 30 minit baru extract, baru dapat optimum. So itu yang kita perlu buat optimization dulu. Duration dia berapa? Kita depend. Kalau sampel tu boleh keluar dalam masa 5 minit, nak buat sampai 30 minit, buang masa. So you have to optimumkan the time. Okay, so kalau time tu keluar dalam 3 minit, the next extraction kita 3 minit saja. Tapi kalau 3 minit dengan 10 minit, then you have to go for 10 minutes. So itu perlu dioptimalkan. Guna instrumen. Okay, boleh?
Bantu kami. Oke, terima kasih. Tepuk tangan sekali lagi. Baik, sudah selesai Prof sesi kita. Alhamdulillah sudah selesai sesi pertama kita. Bagi yang bertanya, silakan maju ke depan, foto bersama dengan narasumbernya. Kemudian nanti silakan kontak panitia. Ada reward. Oke, silakan. Tolong panitia reward, so they can take a picture with you privately.
Oh, jangan. Kakak. Enggak, ibu dan kakak. Kakak juga tolak orang ke aku. Ini. Apa siapa kak? Satu ibu kan.
No. Foto-foto. Kamu ikut foto. Oke, terima kasih. Kasih aplaus dong. Okay, thank you very much, Prof, for a nice lecture for us. So, baik, kita masuk ke agenda kedua kita, yaitu penyampaian kuliah yang akan disampaikan oleh Profesor Dr. Senior Muhammad Sapuan Salut. Kepada Profesor, waktu dan tempat, silakan. Saya sampaikan sedikit profil dari beliau. Beliau merupakan profesor bidang komposit material, ya, dengan fokus itu nanoselulosa. Jadi di sini ada dua topik sebetulnya, teknologi nano, kemudian selulosa itu sendiri. Jadi particle size itu dapat berubah karakternya ketika dia berubah dalam ukuran nano. Ketika mikro dan nano itu berubah. Kemudian selulosa, aplikasi selulosa itu sangat banyak, baik untuk food maupun non-food. Nah, ini nanti akan disampaikan oleh beliau. Terima kasih. Beliau merupakan staf pengajar di University Putra Malaysia. Publikasi beliau sangat banyak sekali. Mudah-mudahan menjadi tambah wawasan bagi mahasiswa semua, khususnya yang tertarik kepada bidang biokomposit, penggunaan nanoselulosa. Nah, sekarang penggunaan nanoselulosa itu penelitiannya sangat berkembang. Saya sendiri juga ada penelitian terkait nanoselulosa. Jadi bagi mahasiswa yang tertarik, nanti siapkan pertanyaannya menjadi bahan diskusi langsung dengan Profesor Sapuan. Baik, kepada Profesor, waktu dan tempat kami persilakan. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Udah, dari pagi, dari email. Yang tadi ibu yang Andalas ini ya, Prof. Iya, iya. Andalas. Ada? Ada.
Yeah, okay, once again, Assalamualaikum, and good morning to the, I would like to thank Ms. Andalas for inviting me as in a world-class university program here from the 21st to 27 May 2023, but I only managed to come yesterday because of some problem. Okay, next is some background. My current H index is 106 and citation 41,407, and the topic of my presentation today is I'm given the topic to talk. Initially, it was agriculture-based biocomposite, which is my main research area, but I came to know this morning that I have to focus on the nanocellulose, it's part of my research. Boleh faham ke saya punya bahasa Inggeris? Tapi kalau dia nak cakap bahasa Indonesia, saya akan cakap bahasa Indonesia langsung. Saya ni apa namanya? HSC Australia, I did Indonesian language. I got A, so I can speak in English.
Indonesia English.
Faham ke saya cakap? In English okay tak? Masih tak faham.
Indonesia better bro.
Dan kebanyakan apa yang saya cakap saya baca dan itu boleh faham tak my English? Kalau tidak saya campur-campur lah. Okay. The title initially I was given agricultural based biocomposite. It was submitted 1 month ago, but this morning I come to know that I cover the topic trend and research on nanocellulose, past, present, and future. But don't worry, because my research also cover partly on nanocellulose composite, biocomposite. Okay, that's going to be at the end of my. Okay, I think I would like to share some of my recent achievement. I'm the recipient of the World Academic Science Award in Italy by the World Academic Science and Society of Automotive Engineer Medal of Quality Leadership in USA. Last year I was Detroit, received the award. I CESCO Science Award from the IC, and from Azerbaijan, UK, and Kawarazmi International Award, and International Society of Bioengineering Outstanding Contribution Award. I received the award in October this year in China, in Wuhan. And also the Professor of Eminence Award from Aligarh Muslim University in India. And last year I received Icon Academia 2022 from Ministry of Higher Education. And recently I received the IET, Institution of Engineering and Technology, UK, but it's a Malaysian-based in the local competition leadership award. My current index is 106. And citation is 41,447. Okay, next. Okay, my presentation outline. First, introduction, natural fibers, biocomposite, and then I think the last one is going to be nanocellulose composite, and then conclusion. Next. Okay, natural fiber. I think this faculty is Fakultas Teknologi Pertanian. So I believe that this topic is very important for you because I'm from mechanical engineering, technical machine. Tetapi dari tahun 2000 saya buat topik ini. As you know that UPM is the agriculture-based university. So from 2000, the year 2000, I started research on biocomposite or natural fiber, I believe this faculty also, one of the focus is on this topic. We blessed with abundant resources of natural fiber. So Malaysia is blessed with abundant natural resources. Similarly, Padang, Indonesia, fibers, natural fiber can be obtained from these resources, such as oil palm, sugar palm pun aren gapinata or hijau, pineapple leaf, coconut coir and shell, kelapa, roselle, sugar palm, kena, abaca, hemp, jute, sisal, henequin, betel nut, arrowroot ini adalah ubi garut, and cassava, singkong, cornstarch, date palm, rice husk, durian skin, banana seed stem, mengkuang, silk, wool, lava, rattan, bamboo, rambutan skin, and Philippine bagas. These are the example of the fiber that we can use for reinforcement in composite. These materials are generally regarded as agricultural residue or even waste. Sisa. Okay. All these fiber are suitable candidates for reinforcement in composite. Okay, I will introduce to you what is composite all about. Next, give the example of fiber. Next. Okay, natural fiber versus synthetic fiber. Synthetic fibers mainly from petroleum based. Natural fiber from plant, pohon, okay, or could be from animal soil. Synthetic fiber are used in composite industry for a long time. But the negative environmental and health effect of the synthetic fiber, that's why we resort to natural fiber. And then major advantages of natural fiber over synthetic fiber include lighter weight, ringan, renewable, recyclable, abundant, no health hazard, and lower cost. So this is the example of the product, this tray, and this spoon and from the natural fiber composite. So I think that this is relevant to your kepentingan. Di sini kalau ini adalah relevant. Kalau kita belum ada yang melakukan penelitian di sini, saya cadangkan is a good, research area. Because saya bukan hanya di Fakultas Teknik Mesin, tetapi bersama dengan Institute of Tropical Forestry and Forest Product. Institute Tropical Forestry and Forest Product and Crop been there for 50 years. So we are doing this kind of research. Next. Okay, the chemical composition of natural fiber. I listed the example of natural fiber: bagas, bamboo, flax, kenaf, jute, hemp, rami, sisal, coir, and wheat straw. And these are the percentage of cellulose, and they're also hemicellulose and lignin. So the analysis has been done by this for this natural fiber. Next. Okay, I think I just want to compare with this natural fiber and synthetic fiber. Synthetic fiber, it is moisture resistant, good mechanical property. But natural fiber is eco-friendly, low density, biodegradable. It is available. Abundantly available, and annually renewable, less respiratory irritation and low cost. But as far as the synthetic fiber is concerned, it is difficult in recycling. It is toxic material, can be toxic, non-renewable, relatively high price. But for natural fiber, the advantage is inhomogeneous quality, swelling with moisture, incompatible with metric, and dimensional instability. So these are the example of the advantage and disadvantages of natural fiber. Next. Okay, this is the classification of natural fiber. So the top there is natural fiber. It's the fiber. When we have synthetic fiber, the petroleum base, then natural fiber. So we focus on natural fiber. Can be divided into animal, mineral, and cellulose or lignocellulose. Okay. For the animal, we can have from the silk, wool, hair is example, sutra dan sebagainya. But for the mineral, asbestos is the example. But for cellulose, plant-based, we can have from bust, leaf, seed, fruit, wood, stalk, and grass. And the example, leaf, we can have the fiber from banana leaf, for example. PALF, pineapple leaf. And fruits you can have from oil palm and coir. Coir is from the, the coconut. Or from grass with bamboo, corn, and others. These are the classification of the natural fiber, but we have also synthetic fiber. It will be organic fiber like aramide, polyethylene, aromatic polyester, and inorganic fiber like glass, carbon, boron, and silica carbide. This is some mechanical properties of the natural fiber. And take the example of the material that we have, like pineapple, nanas. So the tensile strength can be as high as 167 megapascal. And for the modulus can be 82 Pascal. Compared to the flux, which is not found here in the West. And you can see pineapple and flux, they are comparable, very close. The properties, yeah. And similar with pineapple, for the tensile modulus of the pineapple is flux. I mean the tensile modulus mean the measure of stiffness, keteguhan of the material. Next, please. Just now we discussed on natural fiber. Now we are talking about natural fiber composite. So composite comprises two elements. One is fiber and matrix, and make up composite. Okay. When we talk about natural, the natural fiber composite, the fiber is from the fiber is from a natural fiber, from the plants. Then we have the polymetric, normally polymer, and generally polymer. But we have also a class of polymer which is biopolymer. Biopolymer. We have biopolymer. We have natural fiber and become natural fiber composite or biocomposite. This is all, the agricultural technology. This is your area. The use of natural fiber for the reinforcement of polymer matrix, that is thermoset or thermoplastic, including biopolymer, is receiving attention by both the academic and industrial sector. Boleh faham? Can you understand? Boleh faham? Or something new, baru. Tapi tak susah. The concept is quite simple. We get the bahan penguatnya dari pohon. Dicampur dengan polymer jadi bahan komposit. Composite is very simple concept. Okay, when you talk about cellulose, one is from the same, concept. And then from the natural fiber, we produce cellulose and medicine. Okay, renewable material biocomposite. Okay, I repeat many times so that we understand the concept of composite. In discussion of natural fiber composite, two different types of material we often refer to. Natural fiber reinforced synthetic polymer composite. Natural fiber reinforced biopolymer composite. Why is it different? Apa bedanya? Natural fiber di sini ada synthetic polymer dan juga biopolymer. Biopolymer is plant based dari soya and singkong and they made into plastic and polymer and plastic. We mix with the natural fiber to form biocomposite. Oh, biocomposite can also mean natural fiber with synthetic polymer, and the second one biopolymer. Synthetic here from petroleum based. Okay, the purists in green design, people green, argue that biocomposite are not fully biodegradable with the presence of polymer. So what it means here, when you have the polymer is from petroleum base and you mix with a natural fiber, this is not biocomposite per se. Ada campur, 50% is from the non-biodegradable. But in general, both are considered biocomposite. Okay. An indication of how green a material is determined by the carbon footprint. Carbon footprint dalam bahasa Melayu adalah jejak karbon. Okay, the lower the jejak carbon, the carbon footprint is the better. Okay, we have to have the as low as possible the carbon footprint. So that's why now the aim is to some companies or some organization, mereka strive for having 100% and zero carbon footprint. Meaning that if you have the fiber from plant and polymer is from plant, we get 100% composite from bio-based composite, and this is considered close to zero carbon footprint. Next. Okay. The use of fully biodegradable biopolymer composite has helped toward carbon neutrality or net zero carbon emission. The use of carbon or the fiber and biopolymer from agriculture and forest waste and byproduct in composite has increasingly been intensified. The use of such waste and agriculture byproduct in polymer material provide many advantages like reduction of weight and cost, improve the quality and thermal properties, and recycling of the so-called waste. Next. Next. Okay. Okay. The PLA. What is PLA? PLA is biopolymer. It's plant-based, made from plant, and this is available. I mean, commercially available. You can buy, and the quality is good. As good as many synthetic polymer. Okay, composite material has been used in many different industries with several advantages like lightweight, aesthetically pleasing, high strength and stiffness, corrosion resistant, and other properties. Traditionally, composite utilize synthetic fiber such as glass, carbon, and ramette as reinforcement, with synthetic polymer material like thermoplastic and thermoset and elastomer. I have repeated what I said earlier. In recent years, biocomposite and natural fiber as reinforcement of pillar have been extensively used and bonded with either synthetic polymer and bio-based polymer like starch and PLA. So there are two main group of the biopolymer, either from material that is available commercially, which is PLA, as well as from starch. Okay, yes, here in Dallas University, we have a group of students here. They are working with this starch-based biopolymer mixed with a natural fiber, and then cellulose that, and to make the biocomposite. Cellulose fiber. Next. Okay, now natural fiber were reported being used as reinforcement in synthetic or biopolymer composite are numerous depending on the functional requirement of the product. Natural fiber has been successfully used as reinforcement in polymer composite, and composite are used in different industries, ranging from mundane to the most sophisticated application. And this is one example of the man-made composite. A long time ago, in time of ancient Egypt, this is similar composite. They are made from such a composite they made from mud and some important and the fiber. And they make this building material. Next. Okay, just now we talk about natural fiber. Now we focus more on natural fiber composite. After giving you the introduction of composite and natural fiber composite, now you want to see the advantage and the disadvantages of natural fiber composite. Advantage include low density, high specific strength and stiffness. Durability can be improved considerably with treatment, fiber are from renewable resources. Production requires little energy consumption. Production involves CO2 absorption at the same time as returning oxygen to the environment. Low cost fiber, murah, and low hazard manufacturing process, tidak ada bahaya. Low emission of toxic fume at the end of life, less abrasive damage to processing equipment, and more recyclability. Whereas the disadvantages of natural fiber composite include low durability than synthetic fiber. The quality is less compared to synthetic composite. High moisture absorption, which usually result in performance deterioration. Lower strength, particularly in impact strength compared to synthetic fiber. Greater variability of properties, low in temperature, limiting the metric option. This is the example of the natural fiber composite product that we developed in our lab. Tables, the frame certificate. It's very popular. It's sold a lot of units. I was a head of this project, and the chair made from Kenaf composite, and this is a helmet. This was the project funded by Sandabi, one big company in Malaysia. Next. So now I want to see that. I want to review the natural resources in Malaysia. Even here in Indonesia, oil palm. Okay, oil palm. I think this is the plant, and from there you can have the bunch, and then from there you can get not just from the bunch, from other part of the plant, and you can get the fiber. Yeah, you find it a lot here in chapter. Next. Yeah, with this now we have published one book. Perhaps your library can subscribe, can buy this book. Oil palm biomass for composite panel. It was published 2 years ago. Last year, fundamental and process application. So all the book is on a day different aspect of the composite material, composite panel from oil palm. Next. So the next one important in Indonesia is on the Kenaf. This was cannabis. So this is the plant of Kenaf, and then. Initially, it wasn't there in Indonesia, but we replaced Kenaf, we got tobacco, and then we replaced that tobacco with Kenaf. And initially, I mean, a short plant is about 6 months, and then the lifespan. So from there, we can get the fiber. Yeah. And it's good fiber. Next. So this is the Kenaf plant. Kenaf or hibiscus cannabis, the Kenaf plant. It can grow in different climate conditions. It can grow up to 3 meters high, and in 3 months, with the diameter of stem between 25 to 51 millimeters. Major uses of Kenaf fiber are in making roofs, sand, and paper. This is the example of the Kenaf fiber. You have in the middle there Kenaf core, outside the Kenaf bark. And with all sorts of fiber. Next. This is one book that we published on Kenaf. Yes, I think you can also your library can buy this. And there are a lot of information on Kenaf composite. Next, please. Yeah. Now I will review one recent work that we carried out on mechanical, thermal, and morphological properties of woven Kenaf fiber reinforced polylactic acid compound. Okay, the work is on combination of woven Kenaf. Kenaf is plant-based, right? And PLA, which is the biopolymer, and to make film composite. And then we thought this is important work, never been done before, especially for the woven Kenaf. Therefore, in this study, they examine and determine the mechanical, thermal, and morphological properties of woven Kenaf and PLA composite compared to the previous work. Next, please. Okay, the material that we use for this, the composite will make 100% from woven kenaf. So the kenaf is the onion begini, woven, and 100% polylactic acid film. The woven kenaf was obtained from Aceh, and while the PLA film was supplied by a company in Shanghai, the PLA film has a thickness of 100 micron and it is transparent. So we have the PLA in the form of film. So we mix with the woven kenaf and to make composite. New next. So this is the pictorial, presentation of the woven kenaf and PLA film. Okay, then we layer in the woven form, and the kenaf in woven form and film, and we use hot press, compression molding, and then carry out the test, mechanical, morphological, and thermal property. Okay, this is new work. Next, please. And this is some result, SEM example. The next thing, just the methodology for SEM. Next, please. These are the result of SEM. Just put 50. And then this is some the finding from SEM result. So I'm not going to discuss in details, but most of you are not in engineers and science, the pure science or material intelligence. Okay. Next, please. Okay, the next topic or the next material or the plant that we take out in our lab is the sugar palm or Aringa pinnata fiber. And this plant is available, in abundance in Indonesia. In fact, the Indonesian has started this research, long time ago. And this the fiber is called ijo. Yeah. And we in Malaysia have started this, back in 2005. With one lecturer from Aceh, he came there and introduced the material. And we have, make a lot of effort on this. We produce 20 PhD students, and even we have like a society of natural fiber composite. I'm the chairman of the Society of Sugar Palm Composite. We also now organize 2 international conference on sugar palm composite. So this is the plant. This is the plant, and this is the example of fiber, and this is the woven fiber. It's very unique fiber because it been used, for a long time as the roof atap, as a roof tali, and it can stay for 100 years. This fiber, very unique. So the properties are good. In terms of tensile modulus and tensile strength, they are comparable with many natural fiber or even established natural fiber like kenaf. Next, please. And this is very good example. When I came to Padang, 2018, so I came to Yunnan, and then I went to Pagaruyung. This Pagaruyung, this roof is made from ijo sugar palm. Yeah. This material is a very strong material, and it can last until 100 years, except the fire problem. When there is a api kebakaran, it can persist. But other than that, very strong. That's why those from overseas can go there and see. They are made from ijo. So we are working on that, on this material. Next, please. This is the book that we published in Malaysia. It's called Anau. And then it's published in UPM Press. It won the National Book Award in 2018. And this is the book that we published: Sugar Palm Biofibers, Biopolymer, and Biocompost. So this is from our research group. We look at different aspects of sugar palm. Next. And this is the product of sugar palm. We are mechanical engineers. So we create something. We have the mold, we produce the composite, and we design and then produce the table by handing out. Next. This is being displayed at our university, you know. But no company has come to us to commercialize that. But so we believe that people will be interested. Next. I think this is technology, right? Teknik pertanian. It's different from just pertanian. Teknik pertanian is the one we want to look at in your field. So we join the exhibition on the composite table from agricultural waste. Dari sisa from waste. So I think this term called in Indonesia, not sisa waste, waste in Indonesia is limbah. So limbah, use that limbah, make into production. You got IT, industrial design. Just from limbah. Next. Okay, another product that we made from the sugar palm composite is a solar panel, the PV. So the PVDF SSPF composite is the back panels of the solar panel. We include that, and we did the research. We found that is a lot of good properties. So I wish to commercialize it, but my student is from Gaza, so he's stuck in Gaza, so we cannot. We got the technology, we got all the testing. It's very good. Next, please. So this is the example of the back panels from the solar panels from the sugar palm. In terms of thermal properties and mechanical properties, are very good. Next. So, the advantages: thermal stability, balanced heat dissipation, higher energy harvesting, enhanced efficiency, better reflected properties, lighter weight, of course, environmentally friendly because it's from plant, double benefit of green insulation. It's very potential, in terms of these properties mentioned, but I could pursue the commercial, and you can also try. Aren dijadikan sebagai panel. Tapi kemarin I discuss with one friend. Here also I need a masjid raya. Next week there is a solar panel. But the problem with solar panel is they orang akan curi itu. So this is the problem. But if you can, solve that problem, this is can be solved, and we have a lot of Aren here. Next please. Okay, isi dalam bar milik pimpinan Gerjan 6 Aren atau hijau tingkat keberlangsungan tenaga solar. Okay, this is some research that we carried out the study on physical and mechanical properties of this polymer. This is synthetic polymer with the sugar palm fiber nanocomposite. Next, please. This work introduced the nanomechanical testing through the quasi-static nanomeditation to measure the hardness, structure, toughness, stiffness, and young. Next. We carried out the sugar palm fiber. We do crushing it, and we carried out the testing. Next. This is the example of that. This is the result. A tensile strength based on the state of the sugar palm composite. Next, please. This is the result of the tensile and the modulus of the composite. This is standard. The testing that we carry out for all the materials. Next, please. This SEM to study the morphological behavior of the material. Next. So, the mechanical and physical characteristics make them excellent material for outdoor and life applications. And composite material will gain high compatibility with fiber and matrix. The utilization of short fiber contributed to interfacial bonding This is due to the homogeneous composite structure and substantially improved interfacial metric fiber bonding. Okay, this is the the third material that we focus on aren, hijau, sugar palm, available around you. I came here, we take a lot of photos, in this when I went around this week in 2018. So we also carried out during COVID-19 the development of polypropylene based COVID-19 isolation gown char reinforced with sugar palm starch. Okay, aren. But this time, the hijau kita bukan gunakan sebagai aren kita bukan jadikan sebagai fiber, malah kita jadikan sebagai polymer. Okay, the fiber is from the isolation gown yang dalam during COVID-19, funded by Ministry of Higher Education. Next, please. Okay, polypropylene. The major composition in manufacturing composite isolation gown by the healthcare workers. I think you just show the next. Yeah, the objective of the work is to determine the optimal carbon char yield as PP pyrolysis product using different pyrolysis temperature at different temperature from 450 to 650 degrees C, and we determine the best ratio of carbon char, polypropylene, and sugar palm starch estimately in the ratio of 10 to 40% on compressive strength and calorific value. Next. So this is the schematics of the process. So during COVID, I was offered by the ministry, penelitian context saya, okay, this is the proposal, penelitian on COVID, anything on COVID in your research area. So we come up with that idea with some isolation gown digunakan semasa COVID, PPE, protective equipment and isolation gowns. We throw it, just dibuang gitu jadi sebagai limbah. Tapi we took that and then we pulverize it, hancurkan dari healthcare, dari klinik di, and then we make into the char, char, and we use the process called flow pyrolysis. Initially from that pulverizer yang dihancurkan, we got the PP waste powder. For the powder, we use slow pyrolysis process. Then we have char, and we mix with sugar palm starch. This time sugar palm, not the fiber, but starch from the stem. The kanji, and then we put the plasticizer, we make it starch, and then we got the composite of char and sugar palm starch composite. Then you can use for water treatment, for barbecue, for fertilizer, for many things. Very good. We got patent, one patent from this product, and school, published many Q1 journal. Next, please. So this is different view. A char yielded from thermal cracking of non-woven polypropylene personal protective equipment, where this mixed with a natural sugar palm starch. You see the polypropylene powder, sugar palm and char biocomposite, the green product derived from COVID-19 related product. So what is on this research, you managed to publish 2 books with international publisher from Elsevier and with Elsevier and also Springer. This is authored book. Buku yang kita tulis, bukan buku yang edit from this project. So it's 6 months. Grant was 6 bulan, tapi the result was very huge. The student work with this was a master student. We got a top student during competition, gold medal. Very good project. Next thing. So this is how my student we did a lot of hard work in the beginning to watch the TV, etc. But the time was very strict. Copy. Next. Again, the process for collecting, washing of the PPE. Next. And yeah, this is the process of furnace and pyrolysis of the rebar. Next. Next. Yeah, this further process non-woven from the non-woven polypropylene to the PE into sucking milk and make it into powder. The detail of that. Next. Next. Yeah, this is called pyrolysis. We have that equipment available in our lab. This is how composite was formed. Next, please. This is application. Repeating what I said earlier. And this is some of the result. Mechanical and also thermal properties. Mechanical strength and cooking value. This is the SEM micrograph of that research. Next. Okay. The conclusion from this was that char, reinforced sugar palm starch biocomposite with 30% sugar palm starch content is the most suitable for fuel application due to its enhanced compressive strength as well as combustibility to produce better co-product from plastic. So this is some application of natural fiber composite. Okay, now I focus on the 100% bio-based polymer because just now we have polypropylene. It is it's a synthetic fiber. Now we have 100% fully biodegradable biopolymer. Attempt has been made at UKM with the large type of plant, as I mentioned earlier, and of starch to be used as raw material to make biopolymer. The biopolymer is from starch. Okay, from plant. So in place of synthetic polymer, this biopolymer will use as matrices together with natural fiber to form fully biodegradable biopolymers. I think I'll show you the next one. So some review, Wolf and Son, 2005, they reported that they developed the fully biodegradable biocomposite chair, 100% from plant, from soya biopolymer and natural fiber. I mentioned earlier about PLA. So this PLA is from soya, but they are being commercialized and then they are used by, say, reported by MarQuest, the use of city bus body, badan bus dibuat daripada komposit dari PLA and cork fiber. It's very unique. At the moment, we at UPM we work with one industry, furniture industry, to make this chair, the component of chair from PLA and Knaf and bamboo composite. We got funding from ICOE. Our lab is ICOE, Higher Institution of Higher Institution Center of Excellence, next level. On biocomposite and fiber, we are the center of the excellence, center of reference in national level. So we use that PLA and bamboo to make biocomposite for chair. Yeah, it is international company. Next, please. Okay, it's not a project. It's just, completed 2023. Because last month recently I got the letter. The project is completed using the Ubi Gadong. I don't know whether you have, Ubi Gadong. Can you show me the next one? Next one. Yeah, this is Ubi Gadong. Ada dekat sini. This is product pertanian. Okay. Why is it technology pertanian? Technology composite. You just use making the starch biopolymer composite from Ubi Gadong. So this is how you make the starch. Yeah, you include the from this plant. Dia ada racun, kita buang toksit dia. Dan kita dapatkan kulit dia dan juga isi dia. So from that yellow one, we get the starch. Then we put the plasticizer, and we got the biopolymer. And then the fiber we took from the skin, the kulit dia. And we crush it, make it into fiber, and we make the biocomposite. For packaging, I think people of food, they understand. This is my recent work. Then we just try to, from the fiber we make into cellulose and nanocellulose. This is the topic that I'm assigned to talk about. Next please. This is an example of the work on the, the effect of plasticizer on physical, thermal, and tensile properties of thermoplastic film based on this starch from UV gardeners. Okay, the next one, this is another work, but this time we mix that with the fiber from the skin. We make biocompost. Okay, it's 100% from plant. Okay, next please. Okay, what are the main properties carried out the physical, morphological, mechanical, thermal, and biodegradability property for that starch film? Next please. We carried out the SAM, the morphological studies. Next. And these are also the properties. This is some like routine the testing that you have to do when you work with this food packaging material. Tensile and then SEM, the morphological properties. Next please. Yeah, next please. Okay. Now, from the fiber is from the skin, from the bigadung and in the micron scale. But now we focus on nano scale. So we got this strand from FRGS and to Petras, the sugar palm, which is an RM, but it's not 100% from sugar palm. But this time the sugar palm fiber is in the nanocellulose, in a nano scale. Yeah. And then the starch also from sugar palm. Next. So research on active packaging, especially made from nanocellulose, reinforced starch composite produced bioactive packaging has a great potential to improve the food quality and safety during the food storage. So we were invited by Wiley to edit one book on bio-based packaging, majorly on this nanocellulose. So it's a very good book about. There is chapters internationally. The contributors from Germany and so it's good book that we work on this packaging. We can buy this book. Next, there is some work that we carried out initially on the starch and also the development of nanocellulose. Initially, my student Sahari. Alayarham Sahari, Dr. Sahari, and he was lecturer in Indonesia Sabah. So he worked and developed the sugar palm starch from hijau, from Aren Gapinata. And then Sahari also developed the filler from sugar palm fiber, hijau, with the sugar palm starch back in 2012. Then Sanyang, please don't go. And develop the sugar palm cellulose. Yeah, with sugar palm starch. Yeah, this effect tensile. See, you can see the tensile strength, kekuatannya bertambah dari 2 hingga 5 hingga 10. And then Ilyas, 2018, this is like doing the breakthrough when he insists me that I want to use this on nano. With the biocomposite, we have been doing it from 2000 until 2016, and we started on nanocellulose. And then we developed the sugar palm nanocrystalline cellulose with sugar palm starch. Then sugar palm nanofibrillated cellulose with sugar palm starch. You can see that the quality keep on improving, the tensile strength. Yeah, and we believe that this is very good material, and from then onward we carried out. Next please. This is the paper that was published in Carbohydrate Polymer, and it's highly cited and wins a lot of awards. Development and characterization of sugar palm nanocrystalline cellulose for sugar palm starch bio-nanocomposite. Next please. Okay, this is how we produce the nanocellulose. Yeah. Okay, on the left hand side, the Ilyas there, we just do some very hard work there to get to get this from the stem to get to get the starch, yeah, kita kena potong, kena korbankan pohon aren. We get that starch, we include pesticider, sorbition, and glycerol at 1:1 ratio. And with that, we mix with the fiber. The fiber now is in the form of nanocellulose. Now, initially there, this is the black one, the black fiber is hijau. Then from there, we use some, some new technology in nano technology. We have used the high pressure homogenizer, etc. And we develop the combination of the starch, biopolymer, and also the nano cellulose to form sugar palm nanocellulose reinforced sugar palm starch composite by the process called solution casting. Okay. Next, so this is the beginning. Then we move to other material as well. Next, please. There is the process. And it's going to be important. Currently, we are working with Universitas Abu Dhabi Kama in Aceh. We use similar technique, but using, I think, one plant called banat. I don't know banat here in this. Do you know anyone called banat? One plant like that, a stem. Ada one orange called banat. We have in Malaysia also. When I was kid, I saw a lot of banat trees. But in Aceh, they got a lot of things. So they develop this and get from this plant. They make the nanocellulose, and then we start and get the percent. Nanocomposite. See, this is as you know that when we talk about nano, somebody said that we have graphene. Currently, we are working with graphene. We have got some grant from the industry to work with graphene with the PLA to make the electric vehicle, battery enclosure. Yeah, that was very advanced. But we want to focus also on nanocellulose. We hybrid it with the nanocellulose from oil palm with the graphene mixed with the green epoxy, not just normal epoxy, but epoxy from plant, and we make the product. And this is another area. Another one we also working on. Another student working on that. The same material, nanocellulose with the PLA to make the product. So this is the progress, the advancement from that finding. We know that the graphene. This graphene is very strong. I read one article that we have one string of graphene. You can pull one elephant. Very strong, but it's simple because of the structure. But because of the scale of nano, because there's a lot of in nano, though it's from plant, and when you convert into nano, and then it becomes very, very strong. Next, please. This is the result. We use the SEM and DEM for that analysis for the nanoscale. Next, please. These are some of the results. I think I'm not going to detail. Next, please. Some more political results from the DEM, SEM, etc. You can use this equipment in your research. Next. Yeah, this is again the result, tensile and you can break water vapor permeability and tensile modulus. Yeah. Okay. This one is, interesting because it's another student in Malaya. So we have that sugar palm starch and nanocellulose from sugar palm. Yeah. Now we want to use good packaging. Then we add the essential oil, get cinnamon for the antimicrobial and the properties. So next please. So this is the process again from the plant. We get the fiber and we get the starch from the stem. We make the starch and we add the plasticizer. Then we add the essential oil and we get the acting by the packaging material. Yeah, using solution casting. Next. So these are the example of transparent film of ceramic section of incorporated in sugar pump, nanocellulose as well as sugar pump starch biocomposite film. Next. You want to focus on the, okay, this is the routine experiment we carried out. Next. So this is mechanical properties, tensile strength, tensile modulus, and tensile strength for the film. Next. And result. We also carried out the carried out the antibacterial properties. It's the out to be good. This is the SEM result. Next. So we focus on the full spectrum application for this from the pump from the biocomposite. Next. Okay, now at the end of my lecture, I want to share some of the books that we published in the fiber. You know, you can read my book. You can ask your library to buy book, and so you can. I can share with you some books and related to the biocomposite. Method selection for natural fiber composite, and this also a method selection to I write on the method selection but on biocomposite. It's again related to green material like this. Next. Yeah, this is book on composite technology and neurosis application. Green biocomposite looking at the aspect of design and application. And the composite material for core material and training technology for composite. Next. The absolutely independent on bio-based packaging, and this is the composite looking at manufacturing and properties. And this is the book looking at the application process of biocomposite. Manufacturing process. Next. Next. Yeah. See biocomposite in defense industry in for ballistic impact. And mineral field polymer composite, biofuel, reinforced biodegradable composite. This book related to 100% biopolymer composite, fiber and material compliance. Next. And we work on Roselle, also composite, on specific material for Roselle. Also, okay, about bioeconomy, circular economy, we publish one book. And we are publishing another one, design for circularity. And we are also method selection again. Next. And biocomposite in biomedical application. We have work on biocomposite also. And natural fiber reinforced vinyl ester, vinyl polymer, and the application of biocomposite in industry. Next, please. And mineral fields and biocomposite, and this is the middle one on the starch polymer. Only we focus on starch, and also bio-based polymer, other bio-based polymer, starch of PRA. And this is the design aspect of natural fiber composite, but mechanical engineer, we carry out the design. Next, please. And this is my earlier book with UTM Press. This is a natural fiber composite, and tropical natural fiber composite is my book that I've written on biocomposite aspect of design, manufacturing, and characterization. Next, please. A recent book. This is a book that I'm, trying to focus here on nano filler. If you're interested to read on nano, synthetic and natural nano filler in composite. So the book that you can read. And when we talk about limbah, this is maybe the good book that you want to read, recycling of plastic, metal, and other composite, or recycling of that limbah. Okay, this topic, I got 2 books on nanofiller composite. I got impact 3. I didn't put the third one. Next one. So biocomposite in aerospace engineering and additive manufacturing is a very important topic. So if you want to focus on additive manufacturing, on 3D printing with a material in the agriculture technology, so you can read this book. Next. And this is a recent book, Safety and Health in Composite Material. And it's also composite from the environment, from water environment. Yeah. This one is on the pulp and paper. If you are working on some pulp and paper, so I don't know whether you have pulp and paper in this faculty. So we can go pulp and paper and plant based. And so this is another book on bio and synthetic based composite. Next, please. Okay, I cannot show all, but this is only example. So as a conclusion, biocomposite, very important material that a lot of research and significant research work have been done on fundamental aspect of biocomposite. So a lot of work on characterization and mechanical properties and morphological properties, a lot of work there. But we also focus on the advanced application that require the collaboration too. Of course, I've been working with this topic on biocomposite since 2018-19, 2008. 2008 Andalas kita Fakultas Teknik Universitas Abram. From 2008 we work at Andalas. We start publishing one work in 2010, which are Q3 at that time. But what biocomposite within the game Italian, which is from Keladi Bunting dalam bahasa Indonesia kan Encong Gondok. So we will put 5. So Encong Gondok, and then we have Encong Gondok with the here in Padang a lot of Bangkuang, Sengkuang Malaysia, Sengkuang with Bangkuang. Bangkuang is the source of starch. Product biopolymer, making film. And so we work with the Abram on nanocellulose from ginger, jahe in bahasa saya Jawa, ginger bahasa Melayu Jawa halir. So we did a lot of work on ginger as well. One of the tasks when I was invited here to work on books from Abram with Elsevier on the composite from the tubers and roots, which is Bangkuang and halir, all these things, and jahe and potato, sweet potato is very unique. So we put more on root and tubers, composite, like earlier I showed you, composite from aquatic environment, from the pond, from the rivers and ocean, which include the ancient Bangkok. So it's the water hierarchy. Very interesting. We work with composite, you can do a lot of things. And now we have these 3 candidates from Yunnan who joined UPM as a tour. So we are working for the scholarship with BRAIN. So Adlan and Habib, another one is and so 3 of them will hopefully join in September to do their master, hopefully for PhD. So we are working in different type of natural fiber composite and nanocellulose composite. So next is the last one. So I would like to thank Ulpas Technology Pertanian Yunnan for inviting me to come here supposed to be for 7 days, but I managed to come for 3 days because of some problem from my side. So despite that, initially I canceled the trip, but on Sunday I decided yes, I must. This opportunity is seldom come in my life, and to come here will take long time to apply from the Vice Chancellor and from Ministry. And so invitation from the rector. So I honor this invitation. Despite my limitation, I take them that I'm here already. So I hope we can together make use of this opportunity. So we decided with the student there to write Q1 papers, and we ready for the Q1 papers and also books, and also with other collaboration like meeting with the staff. And I'm open for any collaboration or work together because I'm very actively working with Indonesia University. Last September, I went to Universitas Budian Tama, so in collaboration with Putra, I think Putra University here. Last night, I had dinner with my former student, who's a lecturer in Putra University of Padang. I'm from Putra University, in Malaysia. So Padang also, TEBA. So I decided to work with the TEBA and TEBA. So going again for the conference in TEBA in Balikpapan in Mata, we will use the rector is from here, Abraham and colleague. So a lot of collaboration can be done, a lot of papers. Even one student here, former student they are here in Payakumbuh, Polytechnic, we publish a lot of papers. I think you are from top university in Indonesia and more. With that, ladies and gentlemen, I would like to thank you for your attention and apologize because I cannot speak today in Indonesian because he was prepared in English, so I'm more comfortable to the language I prepared. So I hope we get benefit any question. Thank you, sir.
Thank you very much, Professor. Okay, nice information for us, Professor. So, Profesor Sapuan telah menginformasikan kepada kita, mahasiswa, tentang potensi fiber, ya, natural fiber dalam menggantikan synthetic fiber. Banyak produk yang bisa dihasilkan. Actually, Prof, we have a subject regarding this. We name it lignocellulose subject and starch technology tool. But mostly the student take this class for a final year student. Seperti yang sudah disampaikan tadi, potensi dari natural fiber ini sangat banyak ya, mahasiswa. Saya sudah sampaikan. Pertama, dari bahan baku. Bahan bakunya sangat banyak di Indonesia. Prof sudah sampaikan, even di Sumatera Barat. Apa yang paling banyak di Sumatera Barat? Di Pariaman. Ya kan, sawit apalagi. Nah, itu sangat, dari bahan baku kita sudah sangat potensial. Kemudian dari produk akhir, anything we can make the product from the biocomposite. So we can make everything by the biocomposite. So it's very nice information for us. Kita masuk ke sesi tanya jawab. Kita buka sesi tanya jawab. Mungkin dari bagian ini. Yang tadi, ada yang mau ditanyakan tentang topik ini? Ada? Oke, yang di atas? Paham? Mau? Mau ya. Dari tunjuk itu biasanya mau. Ya. Oke. Anything? Baik, Assalamualaikum warahmatullahi wabarakatuh. Saya Ilham dari TPAK 1. Izin bertanya, Prof, mengenai biokomposit dalam penggunaan biokomposit ini, selain dalam untuk tanaman, kita bisa gunakan dalam media apa aja? Mungkin sekian dan terima kasih. Bukan, selain dari tanaman, apakah bisa ada di source yang lain?
Biocomposite. I now can be natural fiber, can be composite itself, can be divided into mainly synthetic and also bio-based. From bio-based, natural fiber can have the fiber from plant, pohon, okay, and then from animals, haiwan, binatang, and so from the minerals. I read two books on minerals from asbestos, from basalt. This one aspect. It's all natural, but majority of the biocomposite is from plant-based, called lignocellulose, also the nanocellulose. It's all from plant. Yeah. And plant itu bukan dari tanaman, tanamannya plant kan. So ada tidak dari binatang. So currently sekarang ini kami sedang tulis buku, sudah dibuat kontrak, sign kontrak dengan Elsevier on animal derived biocomposite. Biocomposite dari sumber binatang. Contohnya dari apa? Dari bulu wolves, bulu kambing, bulu sapi, dari kulit sapi, dari sutra, silk. My colleague from UKM, Professor Sunan, work on silk, and we can also have the fiber from chicken feeders, bulu ayam. Yeah, bulu ayam. We can have the fiber from even from the ocean, aquatic environment. Contohnya hydrosan from shell, kulit udang, kulit kepiting, kulit kepiting. Kulit ni kita buat hydrosan, so it can be sort of composite, biocomposite. And also go deep now, you can get spongine, you can have the collagen-based composite. It's all animal-based. And you can also have the different parts of animals, if you like, to make the biocomposite. Okay? Not just plant. I have shown you 2 books on mineral-based composite. You can consider mineral is also, you can consider it as the bio. You like to have that. Yeah? It's given that it's been classified as the natural material. Yeah? Not just plant, but even plant is innumerable. You can, I mean, for what kind of purpose? You know, you want to go for very high-end application. Not just the plant itself you use, but the technology, the design. But people in engineering, they can do that. In machine, they can do semi-structure. They can do semi-structure. They can do layering. They can do nano hybridization. Hybrid dua fiber kita gabungkan. Macam saya tunjukkan tadi, kita ada kenal tapi dalam bentuk woven, anyaman, sama dengan PLA tapi dalam bentuk film. Not just the powder. Okay? So many creativity, innovation can go into that. Not just the materials. I went to Jember. Initially, I came here in 2018 and I attended the VIVA S3. Dr. Asrafi is a staff from Jember. He invited me in 2019. So I went there. One lecturer showed me one plant. It's Ubi Garut. Ubi Garut. So I got the idea. I went home. There's one student want to do PhD. Okay, you do PhD on Ubi Garut. Dalam bahasa Melayu, ubi bemban. Ubi bemban ni macam carrot. Boleh. Warna putih. Macam robak putih. Ubi Garut. Masa saya kecil tu ada pohon, ada tanam. Tapi bila tanya keluarga saya dalam grup, dia orang tak tahu. Blank. But Ubi Garut we took the skin, cut. And then make it fiber. And then we have the isinya, kita jadikan kanji, starch, campur dengan plasticizer dan jadi biopolymer, we campur dapat jadi bahan untuk packaging. It was published in a good journal, scientific report and everything. Then now we got one grant from Jordan to work with that Ubi Garut and in nano scale, it's nanoscales. So many things you can do. A lot of things you can do. Thank you.
Okay, thank you, Prof. Okay. Next question, Prof.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Halimatul Sa'diah daripada Jabatan Pengurusan Tanah Institut Malaysia, Faculty of Agriculture. Ya, pertanyaan interesting ya, produk-produk yang dihasilkan daripada biokomposit. Di sini ada earthquake. Jadi salah satu cara untuk mengurangkan kesan gempa pada structure adalah menggunakan natural fiber dalam konkrit. Tanya saya, adakah macam mana kita nak contoh kita menggunakan waste, natural waste untuk digunakan dalam satu produk, macam mana kita nak jaga kualitinya, sebab kualiti waste tak sama dengan kualiti yang bukan waste daripada sumber yang aslinya. Keduanya, adakah proses yang perlu dilalui oleh waste tu sama cost efektifnya dengan natural fiber yang bukan waste. Itu soalan tu.
Pertama, tahun lepas saya di Aceh. Saya di Aceh di Universitas Abulia Tama. Saya duduk di hotel. Masa tu pukul 4 pagi. Tengok, hati tu goyang. Memang ada gempa bumi. Pukul 4 pagi saya pun turun bawah. Tengok semua lah turun kat bawah. Yang dah biasa. Jadi berlaku gempa bumi masa saya kat sana. Jadi masa saya nak balik tu dengan rektor, saya duduk, let us go for this research. Di sini banyak gempa bumi. Adakah sesuai natural fiber composite ini digunakan sebagai bahan untuk mencegah seismic protection? So yes, there's a potential because natural fiber ni dia ada sifat meredam paparan dan sebagainya. So we can explore that. So far, because see the problem with natural fiber ni, benda-benda yang simple pun kita tak pernah buat lagi. Dari testing pun tak ada. And even now you will find the product itself, not many. So kira gempa bumi ini adalah advanced research. Kat New Zealand ada banyak buat. Tapi saya percaya ada bahan-bahan biocomposite dia adalah peredam bunyi, peredam getaran dan sebagainya. So dia ada sifat itu. Tapi kajian tak pernah dibuat lagi. Jadi kalau kita nak buat, kita start we get some student and they apply grant. I don't know. Saya bila ada demand saya buat tu ada. Kita pergi Jember dapat Bubi Garut saya bagi PC dapat nano. If you want to start, I think we talked last week that topic, very important topic because when Sumatra got a lot of gempa bumi, so kita boleh start some research. Start with small. And then the second question is about the natural fiber composite waste and whether the quality degrade, ada kualitasnya jatuh, tidak sebagus bahan-bahan yang tidak limbah. Selain limbah, saya rasa tidak. That's why saya introduce is aren hijau, which is available a lot banyak pohon aren. Pohon aren ni kalau you lihat, I don't know about kena oil pump dia degrade, but aren ni ada hijau mempunyai sifat yang bagus, dia boleh tahan beratus tahun. Kecuali api. Tengok istana Pagaruyung, dia punya atap dari hijau. So, kami dah buat kajian, antara yang awal kami gunakan hijau ni sebagai bahan dalam bot sampan. So, sifat aren ni lagi lama you rendam lagi kuat. And then Sultan Melaka, di zaman Kesultanan Melaka, mereka menggunakan hijau ni sebagai tali bot, tali kapal. Dia tahan air, dia tahan macam-macam. Baru ni ada kajian, saya dapat ada teman saya penasihat company dia di Tasikmalaya, saya nak pergi company dia. Dia kata terdapat bangunan di Indonesia ni yang telah beratus tahun, kan? Tumbang bangunan tu, tali yang mengikat bangunan tu masih utuh lagi. Dan dia digunakan untuk buat rakit, dibuat jambatan, untuk dibuat atap dan sebagainya. So this is example kalau you nak tengok bahan bio komposit, bahan kalau kata bahan limbah yang mempunyai kualiti yang bagus. Yang lain memang degrade. Macam kelapa ke sawit kelapa ke andang kelapa ke dia degrade tak lama. Kecuali satu perkara yang boleh kita mengelakkan dia dari degrade ialah kita encapsulate dengan polimer. Kita encapsulate polimer komposit fiber di dalam, di luarnya plastik. Plastik ni tahan lama. Orang ada masalah sampai 110,000 tahun tak degrade kan. So digunakan bahan yang tak degrade sebagai cover inside natural fiber. Because in my house 2001 I have the final year student to do chair. Saya ada telefon stand. Itu zaman telefon yang macam tu kan yang letak. Telefon stand tu dibuat daripada fibernya dianyam banana pisang. Dikabarkan dengan epoxy. Produk itu masih ada kat rumah saya lagi. Saya gunakan sebagai meja kecil lah letak. Apalah. So di sini ada dua perkara. Satu, the fiber itself tak degrade, which I can recommend hijau. daripada pokok anau. Di Negeri Sembilan banyak, di Perak banyak, you can find in Indonesia. Here you find a lot. Number two, you encapsulate it inside, bind it with a natural fiber, with a polymer. And the last question tu tentang apa? Cost. Okay. Cost depend because it is cost free. Kalau you gunakan bahan apa nama? Kalau you pergi ke ladang tebu, orang buat air tebu, you minta dia bagi you free, dia buang. So in terms of cost is free, and cost free. But in Indonesia, they have a very good technology. Pekalongan, they have good in the textile. Pekalongan dia buat baju. Baju yang saya pakai, saya beli di Lampung, dibuat daripada pisang, banana. Saya pergi ke Jogja, ada conference di Jogja, ada lawatan kat Jogja. Baju dijual, ini baju ni dibuat dari bulu bambu, from bambu. So technology here is very established on that textile. So, okay, come back to your question, cost. Cost depend lah. If we go for the, di Malaysia, siapa yang mau kita nak sabun kelapa, I think they give you for free. You see the cost that you have to pay, tak banyak. So cost is cost effective compared to certain product, glass fiber you have to buy. The only problem now is the polymer. Polymer is the culprit, difficult in the composite technology, and also fabrication. And you can use manually, but you can make one. But you need 100,000, and this is you need machine like injection molding. It's a cost there. That's why, in Europe, they make automotive component from biocomposite. Mercedes, they use automotive component in Mercedes in Brazil, they make from natural fiber. Depend, you have the money, you can make use of it. Even in Toronto, in Canada, they make kopi, serbuk kopi tu. Serbuk kopi tu dibuat sebagai fiber campur dengan polypropylene, make pod component. See two things lah. The fiber can be cheap, can be free, cost nothing. But the problem, the technology is expensive. Injection molding, handling up. I mean, handling up require a lot of labor. Okay, I think I answer your question. Yeah, the first question is interesting on the bumi. You can start it. Okay, thank you, Prof. Next question.
Assalamualaikum. Prof, my name is Fadilah binti Manian. Okay, I'm a PhD student also from UPM, Muslim Putra Malaysia, and the supervision of Dr. Nazmi Matnawi. Okay, my question is, actually my question has been asked, half of it has been asked by Puan Halimatul Sa'adiyah. I would like to ask, in terms of composite and or fiber, yang mana-mana satu, can it be decomposed or biodegradable at a certain time, such as in a week, in a month, and at exact substance, such as macam dalam tanah ke, kalau di expose pada tanah.
And then second, I would like to ask about cost, when has been asked the question. And third, if I have I think perancangan some celebration because I'm a student, I also a celebration. Some research more on the type of the for us, but actually I'm more on micro, so I don't combine the micro with the fiber, maybe from other ways, so it can be the result at a certain period of time.
About degradation, we know that people complain about this. Orang complain tentang plastik. dia masuk dalam hidung penyu, berdarah kan, itu dalam video. Ataupun orang ada ikan paus mati, dia potong perutnya ada banyak plastik bag. Dia ingat itu jellyfish. Dia makan banyak dah, sampai berkilo-kilo dalam tu, mati, ikan paus mati. So this is the main culprit of the dia kata plastic bag. So basically, composite is just plastic. It's just plastic, whatever material, polyethylene, polyethylene. Composite is exactly the same, except we talk about metal base or ceramic base, have different application together. But on polymer composite, dia sama dengan plastik bag. So they are not biodegradable, and if you go to the ocean, it will stay there for maybe 1,000 years, 10,000 years, they're not non-degraded, and then they kill the animals. Okay. But that is a plastic part, the metric, the polymer. But we have natural fiber. Natural fiber with the synthetic polymer, which is from petroleum. That's why the purists in green technology said no, it's not biodegradable, but even partial biodegradable because they are enclosed by the polymer. As I said earlier, I have this fiber from pisang. I think seminggu dah habis degrade lah. But because the polymer outside there, epoxy, is 10 until 20 years now. Yeah. So the problem now on the biodegradability is not the natural fiber or natural fiber composite. The masalahnya tentang tidak on the non-biodegradable adalah the plastic itself, polymer. So that's why nowadays there is a lot of move to replace, untuk menggantikan synthetic based polymer to bio-based polymer, menggunakan sama ada PLA ke, ada banyak jenis, even starch, but depending on application. Yeah. Now saya tunjukkan badan bas di Spain menggunakan PLA. Apa dia PLA? PLA adalah dari kacang kedelai, kacang soya. Kacang soya boleh buat badan bas. Itu dijadikan plastik. Campur dengan katakanlah kenang. They have enough strength. I mentioned also my chair with the company now with High COE project, menggunakan kursinya menggunakan PLA dan juga bambu. So they have the good strength PLA. So still they are biodegradable. So in term of place, in term tempat, dalam tanah atau di luar tanah. Memang dalam tanah dia lagi cepat. Kalau dia 100% biodegradable, dalam tanah lagi cepat hancur. Kalau ada elemen of synthetic polymer, dia tidak akan hancur walaupun di dalamnya ada natural fiber. That was the convention. So this is, I think I answered the second question. The first question. Second ni dah jawab tadi. The third one ni collaboration. Microbe, antimicrobe. Microbe. Oh, boleh je. I mean, saya pun ada tadi I show you some natural fiber composite with antimicrobial properties. Ada. Kadang lately done a lot of work on that. Even yang tadi tu kita buat kajian bakterial. Itu kan buat dia. Ada. That one is we can collaborate. Ada we have done significant work on that. Di IBS ada alat dia yang buat. Ada good facilities there. Okay. That's all.
Okay, thank you, Ibu Mariza. Okay, last question, Rafli. Okay, one last question.
We make the biocomposite in scale of industrial. In your opinion, could it replace the 100% of market that of the synthetic composite? And are there side effect of it if we replace 100% with the biocomposite? Like it will change the supply for others things. Yeah, did you get it, Prof? And the second question, if we make it in industrial scale, is there any probability we'll make industrial waste of it?
Can you repeat the second?
If we make it in industrial scale of biocomposite, is there a probability of it making industrial waste of it? Thank you, Prof.
Okay, now the first question is on the industrial application of biocomposite. See, when you talk about industry, they are very broad, you know. In Europe or in America, they're very serious about it. I mentioned about Mercedes. This industry, the automotive industry, you know, they are making components from that. Even Proton, our car is Proton, mobil kami Proton. Jadi Proton pernah satu ketika ada satu komponen di belakang yang dibuat daripada oil pump di belakang tempat letak instrumen musical instrument di belakang dekat audio system dibuat daripada composite material from oil pump. UPM supply with one company with Proton, but after some time it stopped. So that's good. And then see, biocomposite is very broad. Can be this product is biocomposite. This plastic bag also plastic packaging can be biocomposite. And nowadays, if you look at the plastic bag, if you notice the bio-based plastic bag, dia sebenarnya bukan hanya plastik bag yang daripada biopolymer, contohnya dari singkong, dari kilang singkong, ubi kayu, tapi dia campurkan fiber di situ untuk bagi kekuatan. It's very composite. I saw a lot of companies even in Malaysia, even in Indonesia, they have done that. That is the industry application. So about waste, I think if you are working biocomposite, industrial waste biocomposite, you are talking about, you know, fully biodegradable biocomposite. So I think there is no waste because you put there and it is dissolved, it degraded. That one is no problem. Bandingkan dengan komponen yang lain. Tetapi the problem with waste ni bila you work with the polymer, it is from synthetic polymer. Natural fiber is from plant, but the polymer is from the synthetic, dari petroleum. That one that has caused the problem of recycling. But if we have with good recycling facilities or technology, it can be solved. Saya rasa tak waste bukan isu sangat. Kalau utamanya bagi yang 100% bio-based polymer composite. You got my point?
Baik, terima kasih. Kita beri applause dulu untuk para penanya. Berikut ada link absen, sudah absen untuk sertifikat nantinya. Kemudian bagi penanya silakan ke depan untuk berfoto langsung dengan Prof. Silakan. Panitia mana panitia? Prof, izin di Prof. Terima kasih atas perhatiannya. Thank you very much, Prof, for the presentation. Okay, so ini sesi terakhir pada kegiatan Stadium General hari ini. Sekali lagi kami mengucapkan terima kasih kepada dosen kami, ya Ibu Profesor Rebunisa, Bapak Profesor Safwan Salib. Terakhir kita sesi foto bersama. Jadi silakan kalian merapat supaya nanti bisa diambil dari depan oleh fotografer kita. Ayo, silakan merapat biar kelihatan. Merapat, merapat. Oke, terima kasih atas partisipasinya ya. Sampai jumpa di event. Oke, yang untuk apa tadi? Yang penanya silakan kontak panitia ya, jangan lupa lumayan GoPay-nya. Ya.